right, hello everyone. I hope everything works and the audio is there. Welcome to the stream. So we have quite a lot of exciting stuff to do today. I hope the stream is connecting correctly. So I see Twitch is up. And let's see if YouTube is up. Yeah, YouTube is up too. Very nice. You're live. No one is watching yet, but I hope some people will find time. I'm aware that it is in the middle of the night for Europe, unfortunately, but that's how it worked out for me to start streaming today. It will be quite exciting, I think, because I will be trying something new, namely putting something together that I don't even know if it will work. On the previous streams, we were working on the iCEBreaker board and these guys here. These iCEBreaker boards are a small FPGA development board based on the specifications by Clifford Wolf, who spearheaded the whole open source toolchain for FPGA synthesis. But it's of course a group effort, so there's a lot of people involved in that project. He is just representing the basically the community, in my opinion. And so we are making a board that will work for their workshops for formal verification classes to teach engineers how to do formal verification. And this board, we already got it to work on last stream. And so based on that design, I also created something smaller because inspired by Valerie, I think that's his name. I should have looked it up. So Tiny FPGA, I'm sorry, I'm terrible with names. So Tiny FPGA, his boards are very nice form factor. I have even one of them here. So this is the board. We need some light here above the camera to make it a little bit better visible. Luke Valente, yes, thank you so much. I'm sorry, sorry man, I'm terrible with names and I really apologize. Thank you, Luke. So these are Luke's boards. This is one of them. It's based on the ICE40, I think, LP series, if I'm not mistaken. And it is quite impressive because it's a really tiny BGA part that he managed to squeeze into a normal process, and that is affordable. So he's making these awesome boards. You should check out his website, tinyfpga.com, I think. Can you post it in the yeah, can you post it in the chat so people can go to your page? This is a genuine open hardware project with open source software, and the bootloader he's working on is pretty impressive implementation of USB directly in logic fabric without a microcontroller, which is, in my opinion, quite cool. So based on that inspiration, I have created this guy here, and this is, if you remember the 1-bitsys, that I have one of them here. Wait a second, where is my magic box here? Another magic box, I have a bunch of them. There we go. I'll put it to the side. So this is the 1-bitsy, and the 1-bitsy is a nice ARM Cortex M4 development board, and that we sell through 1BitSquared. It's a target for the Blackmagic Probe JTAG debugger, so it's mostly a show-off piece for you to test out what you can do with Blackmagic Probe. That is another thing. Haha. Okay, a lot of things that we have here, but I like the form factor of being able to put it on a breadboard, even though I personally barely ever use breadboards. I mostly just design a PCB for things that I use, or I wire it up, fly wire it, because, or use solder breadboards. So for solder breadboards, this is great because it has all the pins are on the 0.1 inch raster. So designs like this, like using something like that, a board, and you can just solder it together. The solderless breadboards, I never had very much luck with them because signal integrity and connections are flaky and this stuff just falls apart. But it's nice for trying out an LED if it blinks, but I barely ever use it for actual prototyping. I rather solder it up like this if I have to make a prototype or a one-off. Otherwise, we just build this directly on a PCB. I think that's the way I roll. All right, so this board I'm planning to use the tiny FPGA bootloader if possible, but I don't even know if these boards work because I wanted to do it on stream and humiliate myself. So so this is what we will be working on today. And the idea I had, so what I didn't do is make a FTDI breakout board that would match the pin header on this board yet, because the main difference between the ICEBreaker board and the bitsy board is the lack of the FTDI chip on board. And so what we will do is use an external programmer and breakout for an FTDI chip to program a bootloader onto this board. The bootloader would mean it's a bit stream for the FPGA that is being loaded by default, and then over the USB connector that is connected directly to the FPGA, we will have a serial port, a virtual USB serial port presented to the computer, over which then we can send commands that will allow us to flash the... I see my chat completely reloading and being confused by it. I'm sorry. Anyways, then we can flash the onboard flash chip, that is this guy here. And this flash chip contains bit streams. So we are not overwriting the bootloader. That is, so what this FPGA can do, it can access several domains, some offsets of addresses in the flash chip to load different bit streams. There is a special cell called wormboot. How big is this? This is, I think, 16 megabyte flash chip, because we are planning to do more than just bit streams on this. What will happen is the bootloader will allow us to write the second domain on that chip, and then the bootloader will warm boot into, basically reset the FPGA and load a second stream that is actual our application. Currently what Luke did, he loads, every time you plug in this chip over USB, it will present itself as the bootloader chip, and then you have to write a new bit stream to reset it. We will look into that later, but for now, what I need to do is create a FTDI programmer for that board, because I don't have a dedicated board with the correct pinout. That's fine. Oh, interesting. I will need the lattice deployment tool to generate a multi-boot image. So iStorm does not support multi-boot images. Interesting. So that's if that's not supported in Ice Storm, this is something we will need, because I want to use all open tools for that if possible. I did install the ICE40UP5k for the ICE40 chips. Yeah, but I think that's the point of the whole Ice Storm thing, that it can decode the bit streams and take them apart, put them back together. I would hope that it supports everything that the bit streams can represent. So Luke is pointing out that you'll need the Diamond deployment tool to generate multi-boot images. There is a special way to put the bit streams together. I haven't tried using the Ice Storm tools. Well, then we will figure it out, I guess, because we will be looking into the Ice Storm tools. I want to do it with the open tools. I don't care for the manufacturer tools, if possible. If we can omit it, that would be great. And I don't really want to use them if I'm not forced to use them. As far as I understand, the whole Ice Storm was meant as a documentation of how the bit streams are put together. So I should be able to read them out, write them, and manipulate them using those tools. And if it is not working, then that's something that needs to be added to the Ice Storm toolset. And we will have to look into that. Hopefully, David Shah will be here, and because he's quite active in Ice Storm, so we will hopefully be able to look into that. Anyways, this is ways off, and I probably won't be doing any of that in the stream. The first thing we will do is create a programmer, program just a normal bit stream directly that is just blinking some LEDs to bring up these boards and make sure that the hardware works. Later on, we will then look into the further complications, namely getting the bootloader running, which probably won't happen today, maybe later today. It depends on how fast we move forward. But knowing how things take time, I somehow doubt it. But it still should be quite interesting, because I will be doing... so what I will be using for the FTDI breakout, it's a really, really old project of mine. It's FlossJTech. FlossJTech I did in 2008. It was meant as a JTech programmer for the use with OpenOCD. At that time, there was no open hardware implementation of a FTDI programmer out there. By now, there's, I think, a plethora of them. Back then, it didn't exist, so I made an open implementation. This was one of my very first PCB projects. So just after my diploma thesis, where I did my first actual PCB design, this was probably the second that I did. And this thing breaks out the chip, and it has nice PicoBlade connectors that we will make a connector for on a wire. And I already looked into the schematics of this guy and realized that not all pins are correctly mapped. So we have two options. Either we modify the source of the iCEBreaker program to use the pinout that is on here, or we will basically cut some traces and rewire it. I think we will do the second, because it will be more fun, I think. Some nice soldering, some nice bodge wiring. People seem to like it last time, so I think this is the way to go. And we will modify this board to have the correct pinout. Yeah. Yeah, and as I said, it would be interesting down the road to figure out if the Ice Storm tools can understand multi-boot images. I would hope that they do. This would be a question to Clifford, how far he went with that. I would hope he did this. If it's not the case, well, then we will have to figure out how the multi-boot images are put together, and probably modify the source code. But this is probably too boring to do on stream, so we will look into that. it looks like they intend to support multi-boot. So yeah, so Luke is sending a link to the code of ICE Multi. So that's good. So we will have hopefully something to go off with. Or go off from. Nothing is too boring. Hey, Chris. Nice to see you. So nice to see Chris Gamma on the stream too. So today will be no KiCad or KiCad stuff being done here on the stream, I think, but we will just look on some PCBs and do some modification. I hope this will be interesting. The interesting other part is I wanted to use this Pico blade connector that I have on that old project, and I could not find a correct connector for it, so we will have to use a smaller one. Anyways, first of all, I think we should look at the pinout of the two projects. So let's see. This is the, there we have pinout. Let's sort them out here a little bit. Okay, so this is the Floss JTAG that I did quite a while ago. I'm actually slightly curious what year that was, but I don't think there is a date on that. Yeah, it has to be like 2008 roughly. When I did this. This is still done in Eagle. This is the times where the open tools were still quite lacking, which is not the case anymore. Thank you, KiCad. And so this design just has this Pico blade connector and the pins assigned here. We can look into the schematic, and in the schematic, this is what we need. We need the AD bus connections, and these will be the programming pins. And if we compare it with the pinout on the iCEBreaker board, we see that ICE clock, then we have master out slave in, and then master in slave out. And this will be the first 3 pins. Then we have a non-connected pin, which here is connected to TMS, and then we have ICE chip select, which we have connected. Then we have one skip again, and then we have reset and add bus 7. So all we need to do to reach the same pinout is to move the TMS connection from pin 19 to pin 24. So that's all we need to bodge on the board. The rest is basically just connecting the pins correctly to a header that we then can connect to the iCEBreaker Tiny or Bitsy. Okay, so let me see. If we look, so this is all wrong buttons here. There we go. So this should be interesting. I didn't check if my camera was running. Okay. So this should be running. Ooh, that's not good. If I should always check if all the cameras are working, but I think the device USB capture. There we go. Very good. Okay, so that's fixed. Anyways, all right. So this is the board. This is the Floss JTAG. Ooh, this is overexposed. My goodness. Is this connected? Yeah, there we go. Let's go and do some settings. Let's decrease exposure. There we go. This should be better. All right, so this is the, you can drag. There we go. So this is the board. And on this board we have this, you can pull out the connector, it's not necessary at the moment. We have these pins that we need to reconnect. So pin 1 here, so I think if we look at the design on here, then we see that TMS, and this TMS is the pin that we need to move. We can disconnect TMS here, and then we could theoretically connect the pin 24, which is reset 23, so this is 24, this pin connected to TMS, but because I don't have a connector that can reach this pin anyways, because we have a shroud that connects only 1, 2, 3, 4, 5, 6, 7 pins, and I don't have an 8-pin one, we can connect to the lower ones so that we get also ground as a reference. So this pin seems to be unconnected anyways to anything. If we, yeah, this is completely unconnected. This means we can just connect to here, so cut the TMS or just leave it there. That's even easier. We can just leave it there and connect the additional pin we need onto this pin. This way we will have a nice bodge wire here, and that's pretty easy. And then we can just try programming a simple Blinky bit stream to the board. So I'm glad you like your bodges, Chris. That's I think we all like our bodges. So you see the heritage of the Floss JTAG to the Blackmagic probe, if you're familiar with the Blackmagic probe. So this connector is now the ARM Cortex connector, that is a standard connector. Back then, I was still using this connector that was basically proprietary to our project. But I changed it in later versions of Floss JTAG into ARM Cortex 0.05 inch pitch or 50 mil pitch 10-pin connector. That is ARM Cortex standard. But this guy, this is the serial connection. This still persists till today on the back of the boards. So the heritage went for quite a lot of years of why the connector is here and why it is a Molex Pico blade. Pico blade because we were using it in paparazzi UAV, or a lot of actually UAV projects were using Pico blade connectors for the autopilot connections. And this is a thing that I was doing back then. And people were saying, oh, these are reliable, good connectors. And you could just buy the parts on DigiKey. So that's what we were using. And I still use them and I still like them. Okay, let's see. Which pin do we need? We need the following pin here. Okay, this board, you see how crusty it is. It's really old. Yeah, so, yeah, I hand soldered that thing while I was still at TU Munich in 2008. It has to be that old because it's still the red one. This is the first batch ever. So this will get a new life as an FPGA programmer. Yeah, I don't really have any boards that use this connector anymore. So this is a perfect application of this really old board. Yeah, I still have tantalum capacitors on here. I don't use those anymore if I can avoid it. Yeah, 2 here, my God. And 2-sided load. And these are 0603s, I think, yeah. Is this yeah, this looks all 0603. Yeah, I switched to 0402s quite quickly after that. Okay, nostalgia. Poke, poke. All right, so let's get some focus in here. Oh, this is an application for the stick vise, so that it doesn't float around and it's flat. Stick vise for the win. All right. Can we go up? Okay, there we go. There we go, very nice. So, soldering iron on. And we will connect from here to here. And all we need to do that, maybe I should use some flux to get that old crusty solder a little bit more life. Let's see, I just had a coffee. Let's see how jittery I am. Hot, hot. Is it hot? Oh yeah. Yeah, some fresh solder with some fresh flux. And here the same. Ow! What did I touch? I managed to touch the soldering iron somehow with my finger. I'm surprised how that happened. I think I was resting my finger on the stick vise and touched the soldering iron while doing that. Now burns. Okay, let's add some of this flux maybe. Oh, this is old. This is really dry now. I need a Kimtech wiper. Oh, we have someone in the Twitch chat. OMG Pete. Yeah, nice to have you there. Welcome. And then we have Julian, ex-warrior. Do I have any price target for the icebreaker boards? Well, I do have a price target, but I'm still trying to figure out if I will be able to get the prices that I'm hoping for. It's a bit complicated because dealing with FPGA companies tends to be complicated. They are very much geared towards really large customers that buy millions of their parts. They are not very much used to the fact of dealing with small quantities and projects like what I do or what Luke does, or because the only other project, it's the Arduino that is in this realm, but it is done like it's considered an internal lattice project, this evaluation board. And so they are getting special treatment because of it. And that's why they're also so incredibly cheap if you look at the prices. I'm not very convinced that the quality of the board is as it should be, my personal opinion. But I don't think they care. They just want to get the boards out and make them as cheap as possible. But as you know, I'm trying to make my boards affordable, but also reach certain quality standards. That's why it's great to have all those skilled and knowledgeable FPGA people in the Icebreaker channel. They are giving me really good feedback of what I should look out for, because my experience in FPGAs is not well, in general in electronics, it's like I don't have formal training in this, so I don't know. I know less than I know, so. But yeah, still learning. There we go. Yeah, sorry, I had to clean my tacky flux syringe to get to the board. Yeah. Yeah, but I want to make the boards affordable still. We will see how it goes. The main point is I think we will have to do a Kickstarter before we can nail down the pricing, because we have to have some confirmation that we can get the parts for certain prices. And so far, a friend of mine who was looking into the pricing, he didn't get the price that we were hoping for. So yeah, we have to negotiate. Oh, hi Ananexus. You didn't mean miss much. I was just jabbering mostly. So to recap for those that joined in the meantime, we are building first an FTDI adapter that we can use to program the flash on the new iCEBreaker-bitsy boards. So I just need to add a bodge wire onto the board so that we can create the correct adapter. And we are basing it on an old... Yeah, no, this is not what's going on. The switch off audio on this, because it's beeping. Yeah, so the first thing I'm doing to make a bodge wire is to strip some enamel, as always. And then we have to pre-tin it. Okay. I'm still a bit jittery from my coffee, so excuse me. Oh, come on. What's going on here? Yeah. Soldering with coffee in the system. It's fun. Yeah, it's... I think there should be some Zen school of soldering where you say, well, it's all about breathing. So even if you're jittery, it's all about breathing. And if you breathe right, you can have a steady hand. But I think this is all with always the same thing with precision-related tasks. Like you have target shooting where you have to be very accurate. You have to breathe right, and it's all about breathing. And I think this is similar. I'm still trying to not burn my finger. Okay. So let's do... There we go. Now we can use tweezers to direct it where we need. And we need it think that was a mistake. I should have... Yeah, I have to solder it down. Okay, anyways, blah, blah, blah. Like this, and then let's get a nipper. One must learn to slow one's heart to a stop while soldering and drinking coffee. It's Esden-Tempski's advice. Yeah, I don't know if it's to a stop, but slow enough that you can get things done. Okay, so let's see. Okay, let's see if I can get this tint without desoldering the other side. Now you see it's getting the gunk off. There we go. Okay. Yeah, but if you scratch it a little bit, Esden-Tempski says that it is easier for him to burn the enamel off than. So what I do is actually I pre-scratch it so that there is some surface to work with, and then I use the soldering iron to basically dip the end into the enamel and basically strip it off, and like peels off the enamel, like off the wire when you do that. Yeah, that's not very well visible here on stream, but that's basically what is happening here. It's burning / peeling it off after you scratch a little bit on the side. Come on, you can do it. There we go. Now we should probably redo this soldering job here, because I think I might have cracked it by moving it around. Okay, so now we should have the additional pin connected. Yep. Do we want to measure it? We probably do. That we don't have a short to something adjacent. It doesn't look like we do, but it's better to be safe than sorry. Beeping. Hello? Beeping. Okay. Okay, no short. No short. No short. No short. Perfect. Good, good, good. So now, unless, yeah, no. I was confused about one thing in the design of the board here. Let's see. The board on the back has... Oh, the power connection is only to the back pad of the serial connector, not on the front connector. Okay, so we are good. Yes, so we are good. So we added reset, we added this. Okay, now what we will do is create a cable for, so I will use pre-crimped wires. This is something we have in the 1-bit-squared store. So these are Molex PicoBlade pre-crimped wires. That makes everything much easier. I do have the crimp tool. I could use it, but this makes things faster. And we need 1, 2, 3, 4, 5, 6 pins. So we need ground and then 5. So this is chip select, clock. So if we look at this, there we go. So this is the board, and then we have, this is the programming connector. Yeah, I'm considering that it might be more useful to have this not on the pins here, but have it a separate connector. Anyways, it's just thinking about the next revision of the board. Some people were pointing out I should make the board longer and have all the pins on the sides of the board. But I like the length, I like the aspect ratio of the board, and I think yeah, on the perf board it doesn't matter. It only matters if you have the solderless boards, or you use the snap-on sockets like these. So if you have a socket like that and you want to use it in there. Yeah, I'm not convinced that making it into a longer package is the right thing. It's 5 additional pins, so you would make it, what, 3 pins longer, the whole board, to get, because the programming pins, do we want those also on the side? So these would be 10 additional pins. That is 5 pins longer. So if you make it 5 pins longer, this board, so what is it? We have it an additional 5 pins. So this would be like this much longer, the whole board. It's not a big deal per se, but yeah, I'm not convinced I want to do that, to make the board longer. And oh, so Anna Nexus is debugging a 64-pin IC, and he has to try my technique with the wires. It's like, I don't know if I'm doing it better or worse. It's just, this is something that works for me with the wire stripping. It's still very tedious. I've seen Kate Temkin. Oh, so this is something I wanted to do, is probably, now that there are several people here, I can get to that before we continue on to the next step. So several people, which is really awesome, started supporting this channel on Patreon, as well as on LiberaPay. So thank you so much for that. This is really awesome. And I wanted to give a short shout out to the $5 tier backers on Patreon, because they make things, so because that's the tier, and I promise that I will shout out their names on here. And this is Kate Temkin, thank you so much. And then Kian Mazels, then Bob Miller, and Garrett Kelly. So thank you so much, guys, for supporting this channel. I will do that probably at the very end of this stream too, but I actually wanted to do that at the very beginning of the stream. I still have to get it into a habit of doing that. And yeah, thank you so much for supporting this channel. And yeah. All right. So now let's move on. Yeah, so what I wanted to say regarding Kate Temkin, that reminded me that I should have given a shout out to the people, was the fact that she found strippers for enameled wire. It's like a Dremel tool that has arms that can grip around a cable, and they spin and rip off the outer enamel. I'm afraid that this might be not working for like 32 gauge wires. They are very thin actually. But I've seen then Mica or Scanlime have it on the stream, this stripping tool for enamel wire, and she was playing with it, and she actually was able to strip lengths of enameled wire that was very thin, and that was very impressive. Again, I'm not sure it is the right tool, especially if you are doing really small stuff, especially like if you're in the corner like this and you're trying to strip it on the board to the right length. That probably won't work because the tool itself is like this tool and it has like a head this size. But I don't know, I probably should try it. Link to the tool, it doesn't exist. I don't have the tool. Tool link. It's Kate has to look into that. Oh, Ken Keeter, Kiter, nice to see you. It was great seeing you in Portland. It was great that you made it to Dorkbot PDX. It was nice. So yeah, the next thing to do, we should create a cable for the programming. And that's a PicoBlade wire. I was still thinking if there is something else I should do. Yeah, besides finding the link for the tool, you have to ask Kate Temkin about this, or Mica if they have the link. I think you can buy it on eBay. You know what? Let's look for that really quick. This stripping tool. Let's look together. Oh, come on. I need the right window. There we go. Oh, is that the link? Yes, that's the link. Thanks, Ken. Perfect. Okay, awesome. That's the link. Yeah, let's open it. Oh, come on. I want to pull you. There. There we go. So this is the tool, and it has this weird head. Yeah, this head, and it's basically heads of tungsten carbide tips, and when it starts spinning, there are weights on the back here that flip these to hit the wire in the front, and then you can strip it off. So it does really fast business with wires. But I seen Mica just she had to adjust the rotational speed because otherwise it was twisting the wires, which makes sense. But it looked like these gauges she was using were reasonably small. Yeah, Ken, you are faster at Googling than I am. I'm just jibber-jabbering more than I doing stuff. Anyways, all right. Let's see. So we have the wires. So these are the wires, and yeah, I wish I had a desk camera that could go further away. Haha. So these are the PicoBlade crimps, and we will need, what did I say? I said 6 wires. So it is based on here. We have chip select. We have clock. What is it? CR, CD. Data in, data out. So data out is here, data in is here, clock is here, chip select is here, and then this is reset and this is done. So we need 1, 2, 3, 4, 5, 6 plus ground is 7. So we would need all 7 pins. So we need a black one. We need, then we need 7 different colors. So we have purple, let's see, purple, and then blue, and then yellow, and then, so that's 3. Then we have orange, 4, white, let's take a white. So we have 1, 2, 3, 4, 5. One more. Do we have one more color? Or is it, or are we out? I think we are out of colors. Yeah, I think we have still red, purple, yellow, orange, green. Oh, green, yes. So we have 1, 2, 3, 4, 5, 6. And then 7 is the black. UV reactive pink. I don't have that type of insulation, unfortunately. That would be great though. Yeah, so we have, this shows the colors better, I think, this camera. Yeah, and these are nice PTFE, so Teflon insulated wires. So that's, I like those. And then we need one of those connectors, and all I have is a 7-pin, even though the connector here is an 8-pin. So we will do that, and then after we plug it into the header, which is here, we can then cut it off and then solder it onto a pin header like this, and then into this pin header we will put pins so that we can put it into the programmer, because sometimes there will be pins already pre-soldered. Then we will be able to just plug it in. So we will have 6 pins onto here and 1 flying wire for ground, because it's not in one line, which is fine. Okay, so let me figure out what the pinout is we need. So we need the lowest pin. Not an option, yeah. Story of my life. Yeah, I feel you. So there it is, 1, and we have a black wire, and we just click it in. Come on. Click in. Oh, come on, I'm fumble. There we go, 1. And then in whichever order, I like to use orange and yellow for TX and RX pins for some reason. And that would be the data in and data out. These are the last pins, but we need the pinout still. Board. Yeah, I probably should write down on a piece of paper what the pinouts are on both sides, because the naming on the PCB is completely useless if you look here. So we have this connector. So this is 1, 2, 3, 4, 5, 6, 7. So this would be TMS, and let's look at TMS is ADBUS 3. That would be 3. Then we have next pin is TCK, and TCK is 0. Then we have TDI, TDI is 1. Then we have TDO, which is 2. Then we have TDO, then we have TRST, TRST, which is 4. Then we have the new added pin, which is ADBUS 7. And then we have ground. Did I miss something? I missed reset. No, reset is there. Should be 6. I'm missing a pin. Wait a second. TCK. No, TMS is the first one. TMS is 3. Then we have TCK. Then TDI, TDO, TRST. TRST is 4. Then we have RST, which is 6. So this is 6. Then we have 7, and then we have ground. 1, 2, 3, 4, 5, 6, 7, and this is 8th pin here. And this is G and D. Okay. Now we can check the pinout on the ICEBreaker board, and we need to have so 0 is CK, then we have 1, which is a master out. So this is data in. I should open, ooh la la, now I need a second KiCad instance. Another KiCad instance, please. It will complain that it is already open. Yes, continue, please, thank you. And we want the iCEBreaker-bitsy PCB. And then we can look at the, so SS is chip select, that's correct. Then clock, it's correct. Then reset, CR, C reset. Then we have C done, CD. Then DI and DO, and these are master out, slave in. Master out, slave in. Master out, slave in. So that is ADBUS 1. And master out, slave in goes to DI, because the FTDI chip is the master. DI. Then we have data out. That's the next one. Data out. Flip, 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 flip between the screens. Then we have 3 is NC, and then 4 is chip select, and then we have 6 is C done, and then 7 is CR. So chip reset. Okay. Good. This means we want the data out and data in to be in the first two. Click, and oh, and I already made a mistake because I got the wrong spot. Yeah, and this is all just trouble because I want to have a color scheme that I usually use. Great. What a waste of time. Okay. Orange, yellow. Then we will use purple for clock. Oh, wait a second. Yeah, yes, so this is correct. Purple for clock. Nice. Then we have whatever. Chip select is next. Then we have CD and CR. Okay. And now we can cut off the other side of this cable. Where I also have crimps, but I will cut it off so that I can use the cables for something. Should I take half of it so that it is reusable? Yeah, let's do a little bit less than half, like somewhere around here. And is that the... Come on. Oh, tab. Yep. So yeah, I have the cables plugged in, and now I will just cut it off here so that I can solder it into a new connector and make one more crimp. So I was thinking about using the Molex. It's not Secret. It's they are called differently. The Molex crimp tool. So this is SL. That's the Molex SL series. To use these, and I will only use it on one of the pins, namely the ground, because everything else will go into that connector. I don't have headers that are 6 pins for that series. I have to buy more, I think, and then this will be the way to go. So yeah, there you go. And if we look at how it plugs in, it's like this is the guy. We will plug it in basically skipping one pin. It's not perfect because there's a shroud on the back, but this works nicely. That's Molex Pico blade, ponk. And so we can just skip one. You have to just be careful to plug it in onto the lower end so that we get the ground pin and we get all the signals we want, and they're not connected, we just don't need. I wish I had a bigger header, then it will always go one way and not another. That's the safest way of doing it. But yeah, so this is the connector. So people were complaining about this Molex Pico blade connectors, that they are really difficult to use, and I don't understand what they are talking about. It's a really nice connector. It comes in and goes out really nicely. It's not like locking itself badly, and this is not even the perfect solution where you have both. If you look in here, there's a hole in the back where a ridge on the back of the connector is supposed to go into. And I don't have that aligned at the moment because I'm using a too small connector to go into this this header, because yeah, I don't have it. and it's still working fine. And if they are completely aligned, they work even better. Yeah, anyways, it's yeah, I like PicoBlade. PicoBlade is nice. Okay, so we need to strip these, and to strip them, we will use my stripper. Strip, strip, strip. What is the size? It's like 24 gauge? I don't even remember. No, it's maybe 26. Yep, 26 looks good. Yep, good. All right. Now we have nice colorful confetti on the table. Let's throw it away. And we have this guy, and we want, what, 6 pins, right? 6. Let's do it a 7-pin connector, because that's the full width of the board. And this will hopefully increase the probability of us not putting it the wrong way around in. Yeah, well, that still will not work probably, but yeah. 6, 7, so 8th pin is going to die. And explosions. There we go. 3. Okay. And I want to scrape it down to make it nice and neat. Yeah, it would be probably better to have this programming connector at the very edge where the ground pin is also. Yeah. Yeah, I'm trying to think about the next revision if I will break compatibility with this one or not. Now it's the only time, because later it will be even harder, because more people will have those in their hands. So yeah, I will have to think about all that. I added some issues already on GitHub regarding the icebreaker in general, because we have a bunch of things we have to fix. For example, the clock, if you look at this. Yeah, the clocks on this board is the same baud as on the larger board, because I screwed it up. But that's okay, things happen. Okay, so let me tin. How do I do this? Yeah, let's tin these. Yeah, we want some, I have to pull out some, come on. I have to pull out some heat shrink tubing for this to make a nice neat connector that will last us into the future. Yeah, this is what I like about the PTFE wires. The insulation doesn't melt and shrink when you tin or solder these wires around. Okay, let me remove the ground wire because we don't want it tinned. We want it crimped. So let's see which one is missing. There are 2 missing. Tin, tin, tin. And 1 more. Oh, come on. There we go. This one is very resilient here. What's going on here? Yeah, that's better. Tin resistant. Okay, probably was oxidized somehow. Okay, we have that. More garbage. And we need shrink tube. Let me get some shrink. Oh, I got stuck here. Is the audio still running? Yes, good. My lapel microphone got stuck on the chair because I have the wire hanging out of my pocket. All right, my nice box of shrink tube. We want, what do we want? We want transparent if possible, don't we? Or we can use just some black. Not that it really matters. What do we have here? This is all very thick stuff. Let's use some blue. Because I feel like blue. Come on. Okay, so just cutting some shrinky shrink. Six. We can also do the crimpy crimp. Maybe that we will do that first. Oh, this is where the transparent shrink tube went. It's actually in that set of tools. Yeah, shrinky shrink. Oh, hello, the tinkering corner. Nice to see you here too. All right. We need only 1 crimp. And clank. Yeah. Audible special effects included on this stream. Okay, so let's see. There we go. That is crimped. Yeah, I wanted to crimp all of them like this, but I don't have a plastic header for that has 6 pins, unfortunately. I have only like 4. That's the maximum I have. I have to make a DG key order with a bunch of the different connectors so that I can build whatever I need. So let me, this one should be black because this is ground. Yeah, let's see, do I have black shrink tube somewhere, please? Yes. So how long is this? Yeah, shrink tube from Turnigy. I don't know even how they pronounce Turingy. Not a sponsor, but the shrink tube from certain Chinese model aircraft selling spots is very cheap. So that's what I have. It's reasonable quality. Okay, let's shrink that really quick. Ooh, almost ripped that off. There we go. So that's shrinked. We will be able to connect to ground. We'll probably use a clip for that. Okay, so now we need the pinout. The pinout is chip select. So we need chip select first. So that's reset data. So it's white is chip select. White is chip select. Let's recheck that. Maybe I should chip select is 4. Chip select is 4. Chip select is 4. White. But we can just put the shrink tube on here and get this guy into a stick vise so that it is held in there. Okay, and the first pin, so we will skip one because the top one is something we don't use, and get some tinning going on here. There we go. Let's zoom out. Yeah, so there's some. Oh, can we go out far enough to do this? Oh, it's good enough, I guess. So this is the first pin for us. Let's pretend that all of them. There we go. So chip select goes first. Oh, come on. I want it on top. There. Then the next one is clock. Clock is first pin, so that's purple. So purple gets a shrink tube. Maybe I should just put all the shrink tubes on. Yeah, I should probably do that, because otherwise, oh, my microphone just zipped off. There we go. Yeah, that had to be great. Like rustling inside my t-shirt. I hope you enjoyed it. All right, so shrink tubes. No one was complaining about the audio being weird. I did not realize my lapel microphone ripped off my t-shirt. Not two, just one. Okay. Purple, yellow, orange, green, and blue. There we go. Okay, let's do purple next. Blah. Scroll, scroll, scroll. Okay. Come on. What's going on here? Why is it being such a jerk? I don't understand. I need more solder, I think. Okay. Next is, what is next? Let's look at the board. Chip select clock. So C reset. CR is 7, that's almost the last one, that's blue. CR. I'm trying to figure out what the right orientation here should be, but yeah, I think this is correct now. They're a little bit random now, but yeah, that's okay. Okay. C reset, then C done. C done is next one. C done is pin second to last, that's green. C done, and then then we have data in. Data in is first, and data in first is yellow. Come on, let's untangle this a little bit. Okay, yellow. And then orange. There we go, very nice. Now you can take this off, put the heat shrinks on, shrinky. I'm laughing about Anon Nexus. It's a family show here. Not really. Or if it is a family show, I should cut down on the cursing, I guess. I don't know. Am I cursing in here? I'm trying not to. Trying to be. Okay, that looks nice. So there we go. Have the connector on one end, and then we have the ground pin here. And now we can try programming this guy. We just need a pin header that we can plug in here. Chunk. And then we probably want a clip, an IC clip for the ground. IC clip for the ground. And we need some bitstream to program onto this guy. And I think the easiest thing would be to program just the normal ICEBreaker bitstream onto the board. This is a chaos in here. And I realize what is going on here. This cable on my is really long and falling around my chair and causing issues. All right, it should be better. Okay. There's that. Now the scary part, will it work? So let's go to a terminal. So that's iceprog. I was already looking into that if I need to modify it, but I hope we don't. Then we go iStorm examples, and in examples there's by now iCEBreaker, and this iCEBreaker, we will not be able to light up both LEDs, but one of them will come on if everything goes well. So we can synthesize this. Okay, so now we connect a USB cable. Oh, this is the wrong one. So we need to supply some power to the board like this. Doesn't have even an indicator. Then we plug in this into the Floss JTAG. The Floss JTAG gets some power. It doesn't even either have a. And then make prog. Okay, so let's see. We connect to ground on the corner. Oh, come on. Let's see. Okay, you see this? So this is the stencil actually for this board, but that's a separate story. Okay. There we go. So make prog is ready. Let's see. So ground is connected. Jesus. And then let's hold this against the holes. And then make prog. Let's see what happens. Programming, reading, verify OK. Oh wow. Why are both on? I did not expect them to be on. This is weird. Oh, this is really weird. Oh, because it's what? Oh, because it is reading floating pins. Right. So there are some, so it should have the additional buttons connected. On the PMOD, on the external PMOD, but they are floating and they are just doing crazy shit. Okay. Fine. So now let's let's do that. Let's edit the Verilog. Let's just do this. just do some counting on these. Like that. Yeah. Okay, let's try it again. Yeah, it's doing random blinking. Okay, cool. So that's that seems to be working. That worked. We got it working faster than I thought. Let's see. Yeah, you see it? Oh God! Come on, focus. Stupid camera. Yeah, there we go. Yeah. So. You should be able to see it now. Okay, so it is working. Great, that's nice. Yeah, we could program all of them now and just let's test the hardware. If all the prototypes I built 3 of them. Let's see if they all work. And by just flashing those. It's very interesting. Okay. Oh, very cool. Okay, second one seems to be working. Good, good. And the third one, let's try it. Very nice. Cool. Okay, we have 3 working prototypes. Very nice. So yeah, I will be able to. So now that we have the bigger brothers and the smaller sisters, or vice versa, we can send this stuff to some of the developers. Like we can make a package for Clifford and for Dave Shaw, so that they can have the boards and do some cool stuff with it. Okay, so now we need to get that bootloader from Luke working. So that's what we will be working on next. Okay. So the bootloader. Well, at least to have this enumerate, because if I show you what is happening, if I have one of his boards, so if I plug in his board and we go to dmessage, it just enumerates as new USB device found, and then it is T2Y ACM0, so you get 1 serial port when you plug it in. We want to reach at least that same level as he does. And ls USB shows is a future technology device. It's not what I mean. Uptech camera, where is it? Interbiometrics? No. Manufactured 1209. 1209. Where is it? 1209. 1200. 1200. 1209. That's the guy? Oh. Uh, 1209, 1200. Am I doing something wrong here? Did I mistype something? Okay. Did I mistype something? This is weird. Oh, because it's 21. Jeez, I hate my dyslexia sometimes. So stupid. Okay, yeah. Hi, ICOTC. Nice to see you here. Welcome to the to the stream. Trying to bring up the bitsy boards. So now we have a bunch of these also assembled and working. So soon I will be able to send some dev boards around. They abandoned their USB VID. Interesting. So you're illegally using the abandoned ID, or is this, how is it? Yeah, I heard the bad news, Edmund. I'm really sorry to hear that. It's like the contract did not go through. That's really a bummer. Well, let's hope we can make some good dev boards nonetheless. Yeah. All right. Interbiometrics. What strings did you put in there? CDC data unused. So yeah, there's not many strings that you include in here and you send back to the PC. Okay, it doesn't matter. What matters is we want to reach the same level of functionality. And for that, let's go. I already have this tiny FPGA bootloader. And we need to create a new pin file. There is a project. Oh yeah, so this is the alternative to using. Let me close the door very quick. Okay, so I use the VID PIDs from OpenMoko because they, as the company stopped making their phones, OpenMoko, they made a wiki page where they are managing open source project USB IDs using their OpenMoko ID. So if you look at some like Blackmagic Probe, for example, or some other products from 1-bit squared, they come up as OpenMoko devices. And this is because they are sharing their VID PID. And I think what Luke is mentioning is the PID codes project for for open source projects that is managing that abandoned ID. I'm not sure this is, it's like, I have no idea what the legalities are. It's like, I just know that OpenMoko exists before this open source PID VID thing started. And that's why I use it, because, yeah, it existed for a while longer. I think the open source VID PID thing with this biometrics company started quite much later. Okay, so currently the bootloader is compiling. It's using IceStorm to compile, and I already did that. So yeah, there is nothing to be done. But pins PCF. So this is the config file for ICE40UP5k, and these are the pins. And we will be doing a little bit different. So we have to. Currently, Luke doesn't have a way of managing more than one device in here, so I will just bodge it around until it works, and then figure out a way to submit a pull request for him to support the iCEBreaker-bitsy, and we will look how that works out. So anyways, I will move away the pins file. Is it actually? Yes, good. Pins 40 LP8K .pcf. Into the Linux FPGA manager. So ICOTC is mentioning something about integrating your FPGA board into other small FPGA projects, into the Linux FPGA manager. What is the Linux FPGA manager? Yeah, there's a lot of ground to cover with all the projects that we are doing, all the FPGA stuff with the open source tools, and this community is reasonably young. It's only like what, four years old now, or 2 years old since the iCEBreaker, not iCEBreaker, the IceStorm stuff came to being. So yeah, we have a lot of different integrations and software packages to integrate and make it all work nicely with each other. So yeah, this is an interesting journey. I will copy the IceStorm examples. iCEBreaker-bitsy, and then where's the PCF? iCEBreaker PCF, and this is pins.pcf. It's a FOSDEM talk. Interesting. I have to check it out. So we have already a bunch. So clock is already defined here. I'm curious, can you give more than one name to a pin in the PCF file? I would hope so, because we need a different name here. So subl pins.pcf. Let's open it in Sublime, and then okay. Then view, we want two. Where is it? Layout, 2 columns. There you go. Okay. So that we want set IO, no warn, and then we call it why are these names so verbose? Pin 29 meso. Oh, because it's the pin around the perimeter of your board. Is that right? Yeah, so this is specific to the board that Luke made. This is one of the tiny FPGA. So it is not a generic name here. It's, instead of saying just like Flash Meso or Flash CS, Flash MOSI and Flash SCK, it calls them by pin number of the specific hardware he's using, and then the pin on the FPGA which it is. So okay, I will just, for simplicity reasons, I will just pin clock. So pin clock is this one. So we can copy it over here, and this is 35 on my package. Yeah, that's what I'm doing. Yeah, I'm hacking it in the way I want. So I will just add the labels to here, to my file, because here I already know which pin is which. So I will just hack it in there. Okay, so the next one, RxTX, then LDO, SPI flash. So that's what we need. Okay, let's do that. And then SCK will be, SCK is this one. Then next one is SSB. So what is it? Chip select, yeah, I assume. Clifford named these pins. I would just call it CS myself. Then IO0 is, oh yeah, so that's the question now, because I was checking that just a second ago. So IO0 is Mosey. Mosey. And then IO1 is Miso. Okay, these we don't need because this is for quad SPI and we are not using that for programming. Then we need LED. We need an LED. So let's take this one. Clonk. And then we need the USB plus and minus. And this is on my RX pins here, I think. So 6 and 9. But we will check that in schematic in a second. So there we go, schematic. This is the wrong schematic. Did I close the other KiCad? Oh yeah, I did, didn't I? So KiCad schematic, there we go. Yeah, I know. That's the pull-up, and the pull-up. So we have USB det, so detach. Where did I put it? So 43 is USB plus. Oh, I did it differently than I did on the other board. Okay. So 43 let's call it we need USB chunk. So 3 pins, right? Yep. So it is USB plus is 43. USB negative is minus is 42, and pull up is 38. There we go. So that's that. I hope that works. And the clock we already did, so that would be the last pin, and I think that's pretty much it. So because we have the no warn, we don't have to comment out the pins out of the file, because Yosys will just ignore the pins if we are not using it in the design, which is nice. Now let's try to compile this again. I don't know if I need to change anything else. Is the clock I'm using, the 12 megahertz, is it different than the one this design takes? This is something Luke has to tell me. I could look it up, but for 12 megahertz, okay. Input 48 megahertz output. Okay. Where would I do that? BXV. So this is the PLL. Oh Jesus! Now I have to calculate all the dividers and multipliers. Oh, that sounds like fun. Oh, great. So we are off by a few megahertz. So 16 megahertz versus 12 megahertz. So there is a divider R, divider F, divider Q, and I have to change the values of these. So I should probably start reading what these actually do. SBPLL 40 core. So that's the PLL core. Okay. Multiply by 3. So okay. Yeah, this is where the humiliation starts, because I have no clue what I'm doing. Come on. I have somewhere the datasheet open. Datasheet. Family datasheet. Let's look into that. It's like I would like to see what this dividers, these parameters do. Oh, let's open it here. Yeah, that's exactly right. It's not clear what the hell they do, just based on the signal names. So PLL. One PLL with dynamic, PLL block. We have only one PLL clock. There we go. So reference clock, bypass, S clock, SDI, PLL out core, period out global, diff Q, div F, feedback divider, feedback path. Ground PLL. So this is power supply for this. Voltage controlled oscillator. So this is probably the input. Dynamic table. External feedback. So we need to use div q. Oh, this is the input divider. So we are dividing the input. What are we dividing it by? We are not dividing it at all. Then we have div f, that's the feedback divider. Spec, is that page 7? Am I on page 7? I'm page 2-4. Has a nice formula. Okay, so Luke is giving us the cheat sheet here. That's very nice. Oh, it's downloaded it already. Save. Oh, come on. Downloaded. And new. And downloads. Okay. Let's open it up. Let's move it over. There we go. Okay, so page 7 you said. Okay, let's look at it. Page 7. So this is reference clock divider. These parameters are used to control the output frequency depending on the feedback path setting. Then feedback divider, and these can go from 0 blah blah. Q. So currently, what do we have set in here? Currently we have 2, 4, 8, 8 F, and so it's 2F. It's 16. Oh God. Doing binary math in my head, I'm not very good at it. So 4, so it is dividing by 4 here. Div q is dividing by 4. Let me look at this other data sheet. Div q is 4, q. So the VCO divider, so it is dividing the output by 4. And the feedback divider is dividing by a bigger value. And teeny tiny formula at bottom of page 7. Okay, I'm curious about how teeny tiny that formula is. Oh, okay, it's not as big as I thought. So PLL out, reference clock. So functional description. So we have the reference clock of 12 megahertz times divf divar. And 2 to the div q. So we multiply reference clock by divf. Oh, because there are 2 paths. There is a feedback path simple. Frequency for all modes except for feedback path simple. Because simple path has div q also. Are we using simple? Adjustment mode feedback. Yeah, we are using simple. So it is the last one. So at the moment we have reference clock, which is 16 megahertz, times divf plus 1. So can I go into calculator mode? There's a mode, programming mode, and then we have basically, what is it, 4f. No, 2f, which is 47. So we are 48. So we are dividing by 48. So multiplying by 48. Oh, that's the reference clock. ICEPLO. Haha! Okay. Oh, I love you, Clifford. Okay. Okay. Yeah, what do I need? Where do I put the output frequency? Minus O, it's 48 megahertz. So that's all I need. Okay, yeah. Okay, Clifford, I love you. You're the best. Anyway, so let's just plug this in. I did simple, feedback, non-simple, but simple, right? Yeah, simple, feedback, simple. And we need just this 0, that's correct, and the divider 4, that's still the same, and we just use the 63 instead of, oh, where was I? So in Sonic AS, thank you so much for pointing it out. It's really great. It's I forgot that Clifford wrote, because he mentioned that at some point to me. Yeah, filter range. So Luke is saying the div-q, I expected div-q to be 0. Well, it's not. I don't know. So it's basically multiplying by divf, because that's what the formula says. So basically we take the reference clock, which is what, 1 megahertz? Or is that the input? Is that reference clock is the input? Come on, it's the wrong data sheet. So reference clock is the external clock. So we take the 12 megahertz, multiply it by, what did we say? We multiply it by 64 and then divide by 4. So 64 divided by 4 is 48 megahertz. So that makes sense. And simple, oh, this bottom one. So yeah, it's still multiplying, and then div-q is 2 to the 4th. 2 to the 4th. That's more than I thought. Oh, maybe the naming is wrong. Wait a second. So maybe, because it said ICEPLO is disable simple feedback path mode. That would be disabling it, not enabling it. Yeah, the bottom formula is for the feedback loop simple. So the top one is correct. for non-simple, but that would be -s. Maybe they are swapped, because with this formula it checks out what the tool spit out. But with this formula it does not check out, because div r is 0, so 1, and then div q is much more, namely, so if I, let's see, if I do -s, that still doesn't make any fucking sense. Yeah, it's non-simple, it definitely doesn't make sense, because it is taking 4 and then dividing by 2 to the 4th. If I set it to 0, no, because then because then I'm multiplying the input clock by too little, because okay, so we get the reference clock, which is 12 megahertz. Then we multiply it by div f plus 1, which in this case is 4, and then divide by 4. So we get 12 megahertz out. Not by 4, by 2 to the 4th. That wouldn't make sense. And this one is 64, so 12 megahertz times, so this times, so let's go back to normal. So 12 12 megahertz times 64, right? And then divided by 2 to the 4th. Yeah, no, that is correct. It is correct, Luke. That is totally correct. It's 768 768 megahertz divided by 2 to the 4th, which is fine. Then we get 48 megahertz. That's what you want it to output. So it's correct. Quite a bit of output. Oh, I'm sorry. Let me do this. Is that better? I think that should be better. Can I? Come on. There we go. Should be like this. Is that good enough? I'm sorry about the chat window. Thanks for pointing it out, Torsten. And welcome to the chat. Okay. So, I think these outputs are correct based on the formula in the datasheet. So this is great. So FVCO, so that the voltage controlled oscillator frequency after the multiplication is 768 megahertz, and then we divide it by 2 to the 4th, and then we get the real speed. Okay. Okay. You didn't see the bottom area? Okay. I'm sorry. Someone has to point out if it is covered up. I don't see the stream. I don't have a good stream monitoring setup at the moment, especially when I do stuff on my desktop. So yeah. Now this is adjusted, and this is adjusted. So we should just compile it or synthesize it. My phone is vibrating. Let's see what's happening. Okay, so what happened? It failed. Oh, because, yeah, right. Make file, I should... And this is up 5k. And it's just 5k, right? Device, because the device... Yeah, the device, it has to be only 5k, I think. Couple locations in the file. Okay, I think, what was it? 8k. Oh, you didn't. Okay. 5k. And the package is SP48. 48, I think. Yeah, look, we have to clean this up. I need to put together a pull request. Like, do some work, do some legwork. So 8k. So yeah, I think I have it. And then SP48. I think it is correct. Now I'm confusing myself. SG48. That's the name. Okay, not SP. There we go. It failed because what? That's SG48. Supported packages. Why is it complaining? Device 5k, supported packages SG48. Okay, that's fine. And then failed to place 0 PLLs for 1 of 1. And why is that? Oh. Let's clean it. Because probably some dependency didn't get synthesized right. Yeah, it still failed. Why is it not placing the PLL? One of 1 warm boots. Make file, yeah. So Arachne is not being happy. Good question. Why would that be? Now I'm looking at stuff that I don't understand anymore. I'm sorry. Yeah. Any suggestions what I should look at? Chat, because I have no idea. Yeah, this is the moment where I have to ask. Clifford's hotline? Yeah, I guess. Or David. Yeah, I need one of those guys. I guess I don't know now. Because Dave said he was able to synthesize. He had some issues with the PLL, I think, at the beginning. Let's see. Yeah, if I have to recompile Arachne, that would suck, because I don't want to do this on stream. What pin is your clock connected? Oh, should be the correct pin, because this is the pin that Clifford told me is the direct path to the PLL. So pin clock is pin 35. And pin 35, yes, so this is the pin. And according to the datasheet, at some point we looked it up, this is the only pin that has a direct connection to the PLL input. And that's why we use this as the clock input. So Julian X-Warrior is asking in the YouTube chat what we are up to, because they came back just now. So we are trying to modify and synthesize the tiny FPGA bootloader bitstream to work with the iCEBreaker-bitsy board. So that's what we are trying to do. But I think I hit a roadblock that I don't have an answer for. Maybe it's just confused with the two names. I somehow doubt it. We can do that, but I doubt that this is a problem. I can just do that. Yeah, I broke it. Yeah, no, for now I broke it. Yes. Yeah. So what it takes the BLIF file, and that's the, and it's trying to play. So it is the net that it wants, and then it's trying to place the stuff. And then after packing, so what does it say? Pack, after packing, one IOs, and it says PLLs, worm boots, and BRAMs, 2 BRAMs, carry, and then it is trying to place, and fatal error, and failed to place 0 PLLs of 1 of 1. Wait a second. That doesn't make sense, because it should be saying it's fine because it did place the 1 of 1 PLLs. So there's some check wrong, isn't it? Yeah, I did try to turn it on and off and on again by making clean and rebuilding it. So this should delete all the parts, and then make should synthesize everything again. Yeah, it did synthesize it, but yeah, it is complaining about not placing 0 PLLs. But it's failed to place, and then it placed 0 PLLs of 1 of 1. So it didn't place any of 1 of 1, even though it knows that it should place it. Okay, someone who knows Arachne PNR might need to look into this, I guess. But I'm definitely out of mojo here. I have no idea what's going on here. because doing that for the other chip, it worked nicely. So let's see what Arachne PNR has, like commit wise. Just open a ticket. Yeah. The error message is confusing to me. It's like, what is it actually trying to communicate to me? That's the question. So let's see. In master. Okay, we have to recompile Arachne, huh? 6 days ago. I found for the pin 35, you should use another PLL primitive, the one with the pad instead of core. I could do that, but I have the feeling this patch might be related to this. Let's see what else. Yeah. Okay, so I will not be compiling Arachne here on stream. That's not happening. We already tried that before, and that was very unpleasant for those that were watching. Okay, so let's see. Let's look into the primitive part. What we were tiny bx v in the pad. We just do here, and I assume we change this to pad. Let's try that. Yes, that's the primitive. Oh, does not have a port name reference clock. I'm doing something really weird here. So we are oh, it has a different primitive. So yeah, we are instantiating here a primitive, and so pin clock should be go into reference clock, but it doesn't have that. Now, how do I look up what a primitive has as names, input-output names? Package pin. Ah, okay. So like this. Ah. Oh, it's caps locked. Thank you so much. That's I'm learning. Ah. Aha. Aha. There you go. In Sonic, you're my hero. Rescued me now 3 times in a row. Awesome. Thanks so much. Okay, so yeah, we have something that's synthesized. Let's put it on there, huh? Do you have a target in here for programming? Oh yeah, you do. Nice. I already saw your Python code. I think. No, it was actually Clifford's. No, this was the C code for the programming, the iceprog, that has just an array of magic numbers in it that Clifford wrote. That was funny. Okay. It's not configuring, so that's not a good sign. Oh, there we go. Oh, it starts, but then it dies. Interesting. Yeah, wow. It starts and then dies. Oh, is it trying to load the firmware immediately? The second bitstream? That's weird. It breathes for a second and then so yeah, so we have a bootloader that is starting, but let's see. But then it is crashing. I had a bug. Commenting out the wormboot primitive. Okay, I can try that. Wire boot. Do I have? No, I have to. Okay, we will see if there is still the issue. But it fades nicely. I like the fading. I would make it a little bit slower, to be honest, but you were asking on Twitter about it, and I didn't end up. So Luke posted the fading and was asking for opinions, and I didn't add my opinion. And my opinion is it's fading too fast, a little bit too fast, not much, but I like the fading a lot. Yeah. Now it's staying. Yep, there you go. So let's oh, wrong button. What happened? Shit. No. No, 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 no. I just locked my computer. Okay, so here you go. So it is fading. Come on, you can do it. I hate this camera. The autofocus sucks on it. Anyways, but it is fading nicely on the red LED. Okay, try commenting out warmboot primitive. That will prevent it from rebooting too fast and will allow to confirm the issue. I hit the same bug in ECP5 bootloader bringup. Yeah, Anon Nexus, please get AVE here. We need him badly. I committed a fix to the GitHub repo. You should be able to pull and rebuild it, but put the wormboot back in. Okay, yes, sir. Stash origin. Let's look at what you did. Let's make sure. Just out of curiosity, what did you change? And come on, it will probably crash again. Git-G has an issue, it's crashing sometimes. Yeah? Today? Are you serious? Come on, what's going on here? There is another bug? Yeah, okay, I will wait. Okay. Oh, come on. What's going on with Git-G? It's being jerk. Yeah, there we go. Jesus. Your repository is not liked by let's just merge it. Is it? What? How was it? Jesus. 1 tilde? Jesus. 1 tilde? Ah. Remember, tiny FPGA, you don't make bugs, you make undocumented features, says Anon Nexus. I think that's a great way of thinking about it. There we go. So, what did you do? SPI chip select B and SCK set to 1 and 0 in USB SPI bridge. Huh, interesting. So where do you assign this? SPI end begin? No, update SPI byte counters. Update SPA. There. Always begin. So always set chip select to 1 and SCK to 0, and then if it's idle. Interesting. Okay, so Luke. So Anon Nexus, so you're not the first person that asked that. Oh, also Electronoob, nice to see you here. Hello. I don't know yet. I'm not ready to disclose the targeted price at the moment. It should be affordable, hopefully. So, but I need to have a better understanding of what pricing for parts I will get when I make the full production. I will probably put some of the second version prototypes on the store for those that are very eager to have one. Yeah, that's the status at the moment. So, Luke, I think you should start looking into formal verification. And basically, we should make this bootloader verified so that it doesn't have this weird corner cases. How about that? That would be fun, huh? Okay, so. Let's look at that patch. So it is also resetting the registers. Very nice. So Anon Nexus, it's like this is the priorities, how they work. It's not third world pricing. I don't know what that would be, but yeah, we will see. It's not bottom of the barrel pricing, so that's what you can't expect. Okay, so let's pop the stash. Oh, well, if it makes you money, maybe it can pay for an FPGA board. No, just joking. Yeah, it's more important to buy the tools that you use for earning bread and butter. I completely understand and agree. Okay. So let's build that again. Yeah, this is the same thing with buying an expensive soldering iron or an oscilloscope or a computer or whatever. It's like if the pain threshold, how much you are willing to pay for it, is very different based on the fact if it's actually used for your job where you earn money with it or not. So yeah, no complaints there. Okay, so let's see. So that's done. So let's do this again. Where do I have it? Make proc there. Bump, 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 bonk. Okay, let's see. Oh, it's still resetting. Still resetting. Unfortunately. Yeah, there is a timeout still. What does the message say? Oh, device descriptor read. new full speed device using HCE, HCD, and then ba-bam, and then gone. Yeah. So what are the changes I still have? So I changed just the device, I changed the clock, and that's pretty much it, and then changed the pinout. Yeah, I think so. So log update more fixes for Esden-default to not rebooting instantly. Yes, so that's I will do a full build. So something is still resetting quite quickly. That's weird. It could be that it's not in a multi-boot image. Oh, so the reason, how do I use the commercial tools to convert them into a multi-boot image? Or maybe I can do the ICE multi, because this is ICEPack. Because there's ICE multi, and what do I do? ICE multi input files, cold boot mode, power on reset image is selected by CB cell 0. Yeah, no, you are not doing that. You are just creating the bin file and using ICEPack. And what do? We take ICE multi, take the bin file, right? Tiny the X bin. We select the power on, yeah, two bitstream files, but we have only one. Yeah, we have only one binary file. Or, yeah, there we go. We could put the test bin file that we were playing with, Storm, that worked here, Blinky. Not Blinky, what am I talking? Not iStorm Playground? No, that's wrong. iStorm Git, no, iStorm examples. iCEBreaker-bitsy, example bin. Okay, so that's the second one, -O. Like this. It did something. Yeah, it's twice the size. Well, not quite twice the size. What was Micah using to preview the binaries? Maybe I just do hex dump minus C. I'm just curious. Binary data, lots of binary data. Okay. What did I break now? I don't know yet. ICEBreaker, TFPGA, Blinky, bin. So let's just push that on here and see what happens. Come on. Yeah, that's that. Yeah, so it is booting directly into the test firmware. Okay, let's plug it in again. Yeah, it's basically what is happening. Okay, let's look at that. Oh, I didn't even switch to the monitor. Sorry about that. You plug it in. It fades and switches over to the LEDs. Can you do that again? I know it's not in focus, but the LEDs are visible. Fading, fading, clonk. Yeah. So it is there, and resetting, and clonk. Host detection timeout. To at least check if it will enumerate. Is that? Yes, good. And where would that be? In Tiny FPGA bootloader V, line 149. So just comment it out. Oh, yeah, boot to user design, host presence timeout. Yeah, assign boot. Okay. Okay. Should I set the boot to? Yeah. Yeah, okay, fine. I will do that. Sorry. Screaming at the stream. Yes, I know. Stupid delays. Yeah, that's the annoying part about streams. It's like I do something and it takes a while before I can see that you saw it and then replied to it of me doing something stupid. So yeah. Yeah. 60-second delay. Yeah. I'm sorry. That's how the streams work. I think there should be an option, at least on YouTube, to set the delay for shorter. But I think I do already have set that for like shorter timeouts. Anyways, okay, so that's built. Yeah. Come on. I think I can just do the prog because Now it is not timing out. Ah, okay, so it is unable to enumerate the USB device. This is why it is resetting, I think. Let's try it again. Yep, so that's the problem. So we have some issue with the USB interface. Let's check if I have a... Oh, this looks fine here from the connection standpoint. So if we look at this, so the wiring looks fine. And it's fading nicely, creating this weird effect. I'm curious what is wrong with the optics with the camera that it is causing this. It's like you get this bloom. Huh. Yeah, I do. I do have a USB analyzer. And it is full speed, everything, so it should be good enough. I have a beagle. I need some cables for the beagle. My assumption it is on like clock related or something, but yeah, I need some USB cables. USB cable like this. So, is it fading slower than yours? So let's put that in the screen. Like the C done is also very ethereal. That bloom, plume, bloom, bloom, bloom. Okay, so we have one cable. We need another one with the ancient B connector. Let's see. I have to pull it out of the cupboard. Where do I have one? I should have another USB. This is a rarity in my house. I really thought I had one more somewhere. Huh. Where would that be? Well, this is audio cables. Oh shoot. Where could I have it? That's a good question. Because it's not where it should be, and it's not in my cable bag. Yeah, at CCC I borrowed a cable like that from Kate. You have 3 there. Yeah, thanks, Anna Nexus. It's not. Can you just drop it off here for a second? Okay, I could just steal one from here. Yeah, let me steal one from my label printer. There we go. Indiana. It sounds like fun, but that's I'm not sure if people are that patient on stream to wait for me to come to Indiana. Okay, so let's see, and let's start. I'm really curious how well that will work because as we already established, I'm using the same computer for streaming as I use for the demos. So I think it's here. What is it called? Data center? Yes. 73. Yeah, I've never been, so yeah, I have no idea. Well, then if they roll up the sidewalks at 10 p.m., then you have to party during the day, I guess. Or party at home, I don't know. I'm not a big goer, outer goer, so not sure. Okay, so let's see. We have a beagle. It's connected. What's going on here? So let's record. Okay. Reset target. Now let's plug it in again. Chunk. Wow, so much red. Jeez. Wow. That's quite a lot of red. USB earpiece. Okay, yeah. So corrupted packets. Great. Errors. Yeah, bad CRC. Yeah, no bueno. No bueno. Yep. Anyway, so let's roll it up so that it is better visible here. Wait a second. Yeah, let's do this like that. But yeah, I have to go for a second. But yeah, this is definitely not what it should be. It's possible. That is possible. They doubt it somehow. Anyways, I'll be right back. right, I'm back. Analog waveform 2, yeah, so, okay, anyways, I'm back. Let's see, it's like there's a lot going on here. Okay. Yes, I did wash my hands. I always do. All right, so let's switch on the oscilloscope. Yeah, I have to move the oscilloscope over from the other desk to here, but not now. I have to do it for another stream, I guess. What is the stupidest solution here? So let's do this. I have to put pin headers on this board. That's what I need to do. Maybe we should do that now. Oh, disconnected, of course. How do we do this? This is dumb. Can go also on the ground here. Stiff. Okay. Okay, run. Let's see. Will this indicate something? It's just doing a little bit of a twitch. Yeah, not being able to control it properly is a little bit of a problem. Trigger level, position, trigger. Yeah, I probably should add a wire in here, add some pin headers so that I can access stuff, and add some test wires to the USB pins so that I can a decent digital scope. Is that for you a big purchase? Yeah, I like my Tektronix scope. That is quite old, but it does a decent job. Okay, oh yeah, I can go onto the resistors here, see, so that's not bad. Just need to have a better way of plugging it in and out again. And seeing if I can, yeah, let's do that so that I can free up some of my hands. So let's get a wire, and let's get this. Okay. Okay. We can also check what the so yeah, this is the board, and then we have USB N, so that's negative, So pin 2 on the USB connector minus, it goes through a 22 ohm resistor into USB N and then P. But what we can, oh, good idea. Let's measure that it is actually 22 ohms and I didn't like pull out some garbage out of my magic box, just in case. So let's check, 22 ohms. Yes, it's a different resistor than yours in your design, Luke, I know that. But this is what worked on STM32s, so I assumed it will be the right thing. Anyway, so that's not that. Now, let's solder this in really quick. Yeah, so the Tektronix scopes currently are quite nice. The alternative is, of course, so there's quite a lot of options these days, because Siglent is making decent scopes these days too, not only Agilent, or what are they called now? Keysight? So that's minus. I'm not sure this is. So you didn't put any resistors on your exports. Okay. Yeah, that's. Yeah, I don't think the resistors are critical. They just improve the signal integrity. So yeah, leaving them out is probably fine, but better to have them. So that's one. Two, we wanted a pin header. So let's put one of those nice long pin headers. Where do I have them? I had a bag of these at some point. I was just playing around with this. I have short ones here. I want the long ones though. So I'm putting a header on there anyways. Let's put just another wire on there. I don't know where it is. I don't want to look now. I'm too lazy. Let's cut another one. Yeah. So that's true. You end up compensating for really horrible. So you want to be adhering to the standard, and then it turns out that the devices or the hosts can deal with really horrible stuff because everyone else is doing a terrible job. Okay, where do I want it? So yeah, I soldered one on the minus line. I should probably solder one on the plus line too, just in case. And I should, here is a ground. So let's solder to ground. Okay. Oh, come on. Don't be a douche. Okay. Okay, so now we have, I need this guy, and I need this guy. click, and click. Now it should be easier for me to poke around with it. While I'm poking at the microscope, oscilloscope. Okay, so yeah, I will be there poking at the oscilloscope. I should almost move the camera over here, but yeah, it's difficult. Okay, let's see what we get. There's something going on. Acquisition complete, that's not what I wanted. Single sequence, nothing. Level, oh, where is it? Oh, my cursor was completely off screen. Zero, okay, there we go. Single sequence. Okay, my level is time, so okay. Channel, trigger menu, trigger, edge, falling. Let's try this. Okay. Yeah, the problem is now that I have to trigger onto some data. 500 millivolts. Okay, level. Let's try it again. Until I'm trying to. Whoa! What is this noise? Jesus. Oh, it's when I unplug it. Oh gee. Okay, there was some data. I saw some data. Okay. Let's try it again. Dunk, dunk, dunk. There's data coming. Okay, the question is how, yeah, I don't have segmented memory on this scope, so I will only be able to catch. Okay, this is the first edge. That's not very helpful, huh? Is it? So let's run stop. Let's run and try to, yeah. All right. So let's see, there's some clock stuff going on. Let's run it again. There we go. Yeah, I'm not sure we are catching the right thing. My USB knowledge is also not the greatest. Okay, so there we have some data. So I will make a screenshot of this and send it to the Gitter chat. Maybe someone will be useful. I have to remember what which way was which, because I'm probably catching mostly the computer sending data to the device and not its replies. I wish we could get like analog data on the data center of the Beagle. That would be so useful. photos. Let me get that. There we go. There you go. There's a screenshot. So yeah, anyways, let's see. .2 megahertz. Yeah, I have also the OpenVisla, and I heard that the OpenVisla is more forgiving with Oh, awesome. Well, enjoy some sleep and have a good event tomorrow. Talk to you soon and on Nexus. Have a good one. So is it USB-P or USB-N? This is USB-N, I think. Let's see. Yeah, it's the top one. That's the negative one. Should I connect it to USB-P? I wanted to solder a wire on USB-P anyways. So let's do that. Anyways, what time is it? Oh God, it's already 7:30. Yeah, I think I will have to cut it off anyways quite soon. We got quite far, in my opinion. It's there's stuff going on. Okay, well, that's good. So I didn't screw up at least that. So Luke is saying that at least it looks like correct polarity. So that's a good start. Okay. Tick, tube. Let's see. There we go. We will be soldering another pin here directly to the maybe I want to bend this. Yeah, what we could do also, not analog wise but digital, we could connect a logic analyzer and just read in the USB data using using SIGROC. That would be good. And we could, because I think SIGROC has even decoders for USB, so we could see what's going on there. Oh, come on. Why is it being such a jerk? There we go. A little bit more solder. And this will be an opportunity to whip out Seagrok Pebble. I think that's the working name at the moment. The logic analyzer that I made, that Anon Nexus wants to see happen, and I want to see happen. Yeah, this guy. Have you seen this? Where do I have you? This is the wire of it. And I don't see it. Where is it? Ah, there it is. So that's FX-Grok flat, and that's the logic analyzer, where I can plug in cable, and I have a tiny 8-channel logic analyzer. So yeah, we could use that next. Anyways, we have a wire. I will connect this up. Yeah, and I will do some more work, probably off stream, and I will do some Seagrok setup and connect this stuff to Seagrok and see with the logic analyzer how things are moving. But here is the plus line, USB plus, and let's try to plug this in. There we go. Okay, so run. So this is on plus, and there we go. It's definitely talking. Yeah, I will post pretty much everything into the ICEBreaker channel on Gitter. So that's where I think I will dump the traces, and I can send upload some traces for Seagrok onto the internet for you to see. Luke, I hope we can find the issue that we are having at the moment. And just time for dinner over here. And so I should be wrapping up the stream eventually. Let me see. Really quick, okay. Let me dump this. Come on, upload the photo. It's updated, it's uploaded, now it has to appear. Okay, there it is. There we go. Waiting on the cloud. And this is, there we go. Okay. All right, guys, so we have some quite nice progress. The bootloader for Tiny FPGA by Luke, we got it mostly working. Definitely the hardware, my hardware that I assembled the other day, seems to be working mostly. We got some test bitstream uploaded, and we got some debugging done on the firmware for the bootloader. The bootloader seems to be loading an image if we load a multi-image onto the flash chip, which is also very nice. So we made quite a lot of good bring up progress, and it's awesome. And thank you so much, Luke, for helping, as well as others in the chat, for hanging out and helping out. It's very, very valuable. Yeah, in Sonic, I have to give a shout out to it's like the help you gave us to figure out why it was not working was very, very useful. I'm as I said, I'm learning how iStorm works, and if there's someone who has already more experience and can just help out on the chat, is very, very valuable. I'm not sure when I will stream again, soon hopefully, and we will be doing either this or something else. The schedule is always shifting a little bit. I wanted to again give a big shout out to Tiny FPGA, Luke Valente. He is making awesome FPGA boards. Check it definitely out. He is getting ready for a crowd supply campaign, I think. So subscribe to his crowd supply campaign. Maybe, Luke, you want to paste your crowd supply link into the chat so people can subscribe and get notified as soon as your campaign goes live. We will continue debugging the bootloader and making it more flexible and reusable for other boards. So I hope that will happen soon. Yeah. So again, for everyone who is hanging out here on the streams, thank you so much for being here, and especially thank you for those that are donating a little bit money every month for this stream to be possible and to give me the time to work and create those streams. So a big shout out to Kate Temkin, Kian Mazels, sorry, and Bob Miller and Garrett Kelly for donating to the channel on Patreon. You can find the link to Patreon in the doobly-doo, as well as the LiberaPay page where you can donate to the channel. Also check out the 1BitSquared store and follow me on Twitter and to see what the progress is and what we are doing here and where it is going, and when we have good milestones that we reach. Regarding the iCEBreaker board, there is a iCEBreaker Gitter channel that you can join if you're interested. Please do that. There's an organization now that I created, so it is a dedicated organization for the iCEBreaker. Anyways, thank you so much for being here and joining me. And as always, if you have been, thank you for watching, and see you next time.